Hello, I am Andrea, and what you will hear here covers mostly 1 year of work with Nextjournal, which is also my first Elixir project gone in production. So for some basement experimentation, you can check my GitHub account there. And needless to say, it's a year where I've learned a lot thanks to a great team and experienced developers and crazy ideas and a constantly changing roadmap, say weekly or so. And this is also a story about bending some tools of our beloved community in some directions and for a good purpose. I like to start with this page by Brett Fichter, in which he claims that he laments the lack of writing tools for efficient scientific communication, claiming that the existent writing tools can hardly ensure that words reflect any plausible model of reality. And also that often the methods described are hard to be grabbed and reused. So if we want to rephrase it a bit more prosaically, you can also ask, what can a technologist do against software erosion or code rot? So due to time and transfer of projects from setup to setup. So Nextjournal is trying to address these issues, combining text and code into a writing environment that is also a live programming tool. We follow a computation model which tries to be reproducible by design, using Elixir for managing code execution and Docker on the OS level to actually evaluate code. We borrow a lot of concept from functional and, say, reactive programming also to build a web editor that should allow you to easily publish and probably share your methods and replicate your results. So while we are actually improving on the social infrastructure, I will show you today mostly the editor, which is at the core of Nextjournal. So, well, start from a blank page, and you can insert the building blocks of your article. And yes, when you put some lines of Julia code, the code is executed on our remote servers, and it's executed in isolation over some user configurable Docker image. Then yes, you will see some feedback on the side. Yeah, we decided to support Julia as a first language, and then we couldn't not support Python, and our early test users, they required R that we needed to support anyway. And yeah, and Bash is kind of experimental, but it's used to set up stuff. And so, yeah, so now what's happened when you start another cell, say in Python, then you can reference results exported from other cells. We use JSON to restrict the set of values that you can export. And yeah, and only the values that you reference will be actually exported from the cells above. So there is no global state, and values gets exported to the cells that require them. We also, for all the language that we offer, we support drawing graphs with the Plotly library. Yes. Now, whenever you change a cell upstream and you reevaluate it, a new result struct will be passed through all other cells, and they will re-execute. Yeah. Something like this. So we, yeah. Yeah, but we can also do better than just these things. This is an article which was written by some friends at the Free University in Berlin from the computational biology group. They provided their own Docker Python image with some extra library for molecular dynamics stuff, for instance, that you can configure there. Yeah, so then you can insert some files like atom trajectories, I think, that you can still reference in your cells, and set up some params. And yeah. So you see, when we say we use JSON types or values to talk across different languages, for same language communication, we support, say, a richer type exchange. In the case of Python, we can also serialize functions. And again, you can draw stuff. So the picture that is at the core of this thing is that we want to translate a linear flow of cells with the references and build some kind of graph of maybe processes that will represent what you write in the editor. So in which each code cell is actually a function just of its code and its inputs. So we are trying to make Python believe he's a functional programming language. So say you edit some code cell there, and yeah, the correspondent node will be updated, whatever this means. We will see it later. And then only those nodes, depending on the node A, will be re-executed, giving then a feedback back to the editor. So more or less, this is it. Yeah. So before I go into the details of how we built the graph, we maybe take a tour across the boundaries of our Phoenix application and how we outsource the actual evaluation to some satellite Elixir apps on some other nodes. So the editor application is connected via a Phoenix channel from the browser to Phoenix, okay, over WebSocket. And for the front-end app, our front-end team tried a lot of ways, starting with Elm, for instance, and then rewriting until they settled to the Clojure ecosystem, with which they are quite happy so far. Indeed, they use Clojure script with this reframe framework, which is a wrapper around React, event-based mostly. Then we use the transit format, still developed at Cognitech, to talk from the JavaScript to the Phoenix, to the Elixir part. And this is a richer format than builds on JSON, but allows for extensible type definitions. For instance, you can exchange keywords, closure keywords to atoms and back, or have maps with nil keys. Very important for the closure people. So all article channel PIDs, they report to an article manager which will serialize your edit operations and can rebuild the article state, the code cell information, so that when a run command arrives, it will ask a scheduler to bring up one of our runner application on some agent in the network. And this will ping back the central Phoenix app so that they are then Erlang connected. From this moment on, whatever this graph is can talk directly to the editor over Phoenix PubSub. So reaching through the channel topic to broadcast directly to the editor, or any other topics for internal communication with the Phoenix app. So, and the actual code evaluation is done through Erlang ports on the runner side. We will see this later. What is it about? So the pick of GenStage was not the first choice. We actually started with this tool. This is a workflow language written in Erlang by Jürgen Brandt, which you might have heard already in some Erlang Factory Conf about his language. So what is Cuneiform is an abstraction for foreign language interaction and pipelines of data flow. It's mostly script-based, and it's made of task definitions and queries, which tie together results coming from the different tasks. So what we did in the first place was to replace the Cuneiform parser and build a corresponding Elixir nested serialization of our code cells, which will be then transformed into the Cuneiform AST, which is Erlang terms. So then such terms were then fed to a Cuneiform runtime, which would evaluate the code. So while offering some crazy features like parallelization and complex operation on lists, Cuneiform wasn't the perfect fit for us, because in order to submit evaluation, you need to serialize the whole flow. So in this sense, it's a graph of tasks, but not a graph of processes. You need an atomic workflow to be serialized in order to evaluate. So assume you edit one of our cells in the editor, you would need to find a bottom element connected to this, or more bottom elements, and then serialize the query up from there and submit the whole workflow to our backend. It was fun. We learned a lot how to structure a concept of a node. So, but later we tried out GenStage, which is the actual implementation. So if you see what the authors use to describe it is this brand picture with arrows. I want to remind you that GenServer is an extension of, GenStage is an extension of GenServer, in the sense that if GenServer is an abstraction of state and communication to and from the same a single process, then GenStage adds an extra channel of communication between processes which first need to subscribe to each other. Furthermore, GenStage implements the so-called demand-based approach. You heard Jose before, in which a producer won't emit more events than a consumer asks for. And then the consumer will receive a batch of processes and won't ask again until a usually blocking operation on the batches is finished. This is more or less what back pressure in a flow of source of events and sink should represent. So actually we bypassed the demand approach completely in favor of exploiting GenStage subscriptions. So the idea there is that once subscriptions are subscribed in a certain form, you don't need to think about to whom you are sending some events. So it's mostly like this. Once established, you have this dedicated channel for pushing and propagating events. And for this reason, we actually use stages of mixed type producer-consumers, because they can both handle events and also push them downstreams. Yeah. What we want to do indeed is arrange these processes implementing the stage behavior into a directed graph of stages where the nodes are the stages and the edges are subscription among them. So whenever the state, the article state hits our runner application, we have a graph manager which will start or update these nodes based on their unique IDs. And when a node starts, it will check its own state and will subscribe to the other nodes accordingly. The graph manager will also shut down nodes if they were removed in the editor and stuff. And it will also order nodes so that they are started in some topological ordering, so that no dependent nodes is started before any of its dependencies. Yeah. There's the Erlang standard library for in the dgraph module, so no need to reach out for other stuff. It's in Erlang dgraph manipulations. So, but what we have is indeed a graph with labeled edges, because a cell can require reference explicit values defined from their dependencies. Indeed, we are lucky to have languages that have quite a good introspection, so that we can know exactly what they define inside. And this is mostly roughly what the subscription API will do when you try to subscribe gray to blue, say, except some reserved words, like to, of course. you can paste, you can put whichever terms as options to the subscription, so that you can actually sync subscription data between the two processes. This is because of callbacks, which will be triggered on both sides of the connection when the subscription is acknowledged. So you can modify the state of the process, or you have similar callbacks if the subscription gets cancelled, and so. So yes, this is the API for, say, producing events. So GenStage actually extends, if you see the block below, extends GenServer callbacks with an extra dispatch slot. With this thing, you can actually produce events, and then adds the handle events callback, which will receive events, maybe transform them, and then pass them over in the dispatch slot. So it's quite OTP compliant. Yeah, the similar stuff for calls and info. And so, what is the life cycle of our processes during updates from the editor? So assume this configuration, and the node there depends on A and B, and gets a call which changes its internal state to a new function and the new dependencies. So maybe you want to subscribe to someone else, or resubscribe to the same node with different set of required exports. And then you will check if you have all of your needed dependencies, and you will actually fire if this is the case, spawning an asynchronous evaluation of your task. You will receive some result struct back that you will push downstream to the subscriber nodes of this one. And at the same time, you will broadcast the results to the front end, because you know the topic of this. And you can use PubSub. The same happens if a new result comes from my dependencies. So a result comes, I will check if I have all the others required dependencies to fire, and then I will ask, spawn an evaluation, get something back, push it down, and broadcast the result to the front end. So, and this is another kind of balls. This is what the reactive X paradigm would look like if you have a function like our evaluation based on params like code and a set of inputs. We will actually fire not sooner than having at least all the required inputs, and then we will fire evaluation again when any of them changes through time. Yes, this is what happens roughly in code. We handle events when something new arrives to to the cell. We will receive a result. We will add it to the state. We will check if it's if we can fire, because we have all the results. None of them has errors or so. And we will async schedule the evaluation of my body and with references to my dependencies. Or I will actually push down errors immediately to my subscribers. So when the evaluation is ready, I receive a cast with the result struct. I will broadcast the result to the front end, and I will push it in the dispatch slot to my subscribers, which observe my node. So but for each language, evaluation works roughly like this. We have an eval process which receive my code evaluation specs with body and stuff. This process owns a port to an Erlang port to a language container, pushes down the code through standard in, and receives something back through standard out, and gives the result back to the node in question. Again, through everything is reachable through unique IDs, so that if you know them, you know your processes. Yeah, and this is back to the full picture. We have an editor of cells which pushes continuously its state updates to the database, and we mimic the user interaction into a graph of processes, of GenStage processes. We eval the code when it's needed, and we get something back. We propagate downstream, and we report back to the front end. Indeed, it's a quite colorful message passing picture, because it's indeed at the core it's all Erlang message passing, but we use PubSub, Phoenix PubSub or PG2. We use usual calls and casts, and we use also this new communication, say, protocol of GenStage events, which is again in the end message passing. So, and this is, I finished early. So it's a few remarks, just one. Maybe it's that my experience with Elixir so far, say, I think it's a language that allows you to go from drawings to actually working programs in less than you can expect. And yeah, and it seems a really good fit for our needs. And that's it. And maybe in 1 month or so, we see again here in Barcelona at Curion, where Martin, our founder, is talking about Nextjournal again, and Jose is also giving a keynote there, I think. And that's it. Thank you for listening to this.
All right, fascinating stuff. We're going to do some questions for him until lunch at 12:25.
Thanks for the talk and great use of ports. I wonder if you have plans to handle, when you cross the boundaries across the languages, you have plans to have the ability to have very large data sets that you maybe serialize in another way to pass them through, like with lazy evaluations and database storage maybe.
Yeah. No, we don't. We used to, and we maybe crashed the Erlang VM, but no. Then we learned from Cuneiform that you don't pass actual data. You pass reference to files, actually. You maybe dump, we are working on that. So it's not established, but current solution is you pass all references to intermediate files on the agents. But maybe we will go for content addressing everywhere so that you can duplicate everything, and yeah, there is a lot of stuff in there. Yeah.
I am seeing in your node graph, last node passes data to 2 nodes.
Yeah.
In GenStage, it's not possible to pass to 2 nodes, and you are handling yourself.
I forgot to mention it.
Okay.
No, but the drawing before, if I reach it. So indeed, you can configure your dispatcher type. And we use the broadcast dispatcher, which is built, it's in the library, which can fan off from, you mean this one at the end? The other way around. Yes, from a node you can subscribe to more.
You can subscribe to both, but on the last node, you push data to broadcast data to 2 nodes.
Yes, you can do this. Okay. Yeah. If you choose the broadcast dispatcher, by default, I think it's a demand dispatcher, so the node with most demand will get the things, but there is some more fair dispatcher in the works. If you check the GenStage project. Yeah.
Yes. Do you have some experience of some performance measurements of the specific GenStage processes, like how fast the data item is processed in the whole graph, or do you have some experience on some production environment when message queues are built or some crashes, or how do you handle these kind of failures in this model?
So, as I said at the beginning, it's not the real intended way to use GenStage because we don't really have this such, how do you say, with large flow of events, because it's mostly people typing on a keyboard. So it's not about the demand, so not about measuring the flow on which flows through each edges, because this is really discrete. And so this is no problem. So our problems are of a totally different nature, how to handle. Yeah, good. So the graph works very nicely. So we would have done it, we would have done it by hand, like picking gen servers, storing to whom you want to send, synchronizing, but it comes out that GenStage has exactly these things that we need. Yeah.
Yeah. Like another question. Thanks for the talk. Awesome stuff. I like this a lot. This reminds me a lot of IPython notebooks and Jupyter notebooks, and that brings me, and I like them a lot. And that brings me to the question: can I use this on my machine, or do I have to license by your product website?
Sorry, yeah, of course I didn't say.
Yeah.
It's just host. If you go to Nextjournal.com, yeah, you can try the stuff.
I will do this.
Yeah, I try to
in the
avoid
evening.
the Jupyter.
Yeah, cool.
And we need users, so yeah, please do.
Yeah, that would be my question for the lunch break. Yeah.
Cool. Yeah. I want to go to the last because there is this.
One last question. Also, I guess I should mention, if you're in a hard-to-reach area like this gentleman was, I appreciate if you pass him down the rows.
Hi. what I didn't understood is you have an acyclic graph, but what are the constraints between the nodes? As he asked before, how do you combine them in practice in your project? I mean, in your scenario. For example, you have Python code inside your journal, right?
Yeah.
How do you interconnect them? What are the actual constraints in your system? Like you can make a reference from one Python snippet into another. That's the constraint, or?
Yeah, wait, I try to give you some slides. So, yeah, I was, it's only the surface here. When you, first of all all these languages, also Python, doing incredibly well in introspection, so you can slice the context of evaluation, get new values, Julia as well, R as well. When the results here come back, it carries over all the names that you have actually exported in your script. But still, there is no global state. The port is closed after each evaluation. So result carries back to the just evaluated node all the names that you can require from other cells. So when you then autocomplete those references to this thing, you will know, so on the next execution, you will tell the same cell that it has to export this. So we actually write to file to some path. Then when the dependent cell executes, before executing the script, he will reach out to these references, read the values, interpret them or assign them, and execute. So this is the thing. But we try to avoid global state, and it's, yeah.
Let's have one last round of applause for Andrea.